Good morning. Are you ready? How can you know that you're ready? You know, for many, not years, but decades, ever since I learned about reincarnation when I was about 20 years old, I've tried to talk to people here and there about planning next incarnation, and nobody was ever interested in joining me in that conversation, you know? They were so busy living their lives and being in the here and now, but I always thought that we should really get together and have some workshops on what the heck are we going to do next life, right? And who are we going to be with, and how are we going to play the game? And I don't know if you've ever read this book. There's a couple by this title, but it's called Life Between Lives. You ever heard of that book? Written by a psychiatrist who was regressing people and, you know, matched up people's stories and put together a little wireframe theory of what takes place on the other side. Because there's lots of books, starting with Dr. Moody, about, you know, near-death experiences and the transition from here to there. But this book was about the transition from there to here. And I thought, this is really important stuff. And what the author said was that you get together with a group of your soul buddies or your guardian angel or Jiminy Cricket or the guru, who's ever on your team, you know, in that planning committee on the other side, and you actually script what you want to do in this life. And some things you want to finish up, and other things are so big, you say, well, I'll take a little bite out of that. So you come up with this sort of joint social contract together. Doesn't that feel real, the way that it works, you know? And then here you probably bump into those people through, depending on how sensitive we are. But I think it's a really interesting conversation. And our next speaker, Joseph Selbie, is going to be talking about Sri Yukteswar's predictions and about the Yuga cycle. And when I heard Walter give a talk a couple of months ago on these Yugas, I was just thinking to myself, yeah, there is these different ages. They all have different properties. There is different awarenesses during the ascending and descending periods. It's all astrologically driven, but the whole damn thing is a dream, right? The whole thing is a fantasy. And so once we understand that, we can opt out of our age. We can opt out of our cultural programming, you know, our little defined personalities, and really step into a much bigger picture and live in a golden age. Isn't that a fantastic goal? You know? And the only limitation's up here, right? So I'm really interested in listening to you, Joseph, and tell us and remind us about Sri Yukteswar, who was this very wise man. He was an astrologer. He was a jnana yogi. And of course, he was the guru of Yogananda. So the latest insights from Joseph Selbie.
Good morning, everyone. So I've been doing a lot of research lately on neuroscience, particularly around sleep recently. And one of the fascinating things they're discovering is that when you sleep, your brain goes into this completely different mode of operation. And one of the things it's doing is it's taking all of the experiences of your day and is storing them all as memories. So I'm really hoping that's true, and that everything you learned yesterday has now been stored away, and you have fresh room this morning after the deluge of information that you all received yesterday. So I'm going to be talking about the Yugas, and I'm also going to be talking about science. Most of you probably who know of me probably know of me through the book I co-wrote, The Yugas. And I'm going to touch on that, but I'm also going to marry it with another book, the information from another book that I wrote called The Physics of God. And the whole purpose of The Physics of God is to show to people that there is no conflict between science and religion. The conflicts come through the interpretations of what has been discovered in science and the interpretations of what spirituality is that get down into denominations and dogma. But if you strip away the dogma and you just look at the eternal religion, the direct experience that the saints and sages describe, and you compare that to the actual discoveries of science without any material interpretation, there's this amazing connection between those two. So I'm going to touch on some of what I researched and discovered in the process of writing that book, connecting it with the Yugas. So I'm going to talk about our current age in the Yuga cycle. So for those of you who are not familiar with the Yugas, I'll just give you a very brief idea that there's a 24,000-year cycle as predicted by Sri Yukteswar, and that the highest age was last experienced about 11,500 BC. And then we've gone all the way through this cycle of descending through the ages of Satya Yuga, Treta Yuga, Dwapara Yuga, and Kali Yuga. And now we're on the upswing again from 500 AD to present. And you'll notice I have highlighted in that cycle two ages, both labeled Dwapara. The Dwapara age on the right is the descending age. So it began in 3100 BC, just about the same time as the pyramids started being developed, and ended at 700 BC. And we went into what most people would think of as the Dark Ages. It is called the Kali Yuga, which actually means the Dark Age. And then we came out of Kali Yuga in 1700 AD. We went through kind of a transition period for 200 years. And then in 1900, Dwapara Yuga on the upswing, the ascending Dwapara Yuga, really got moving. So what I want to share with you are some of the qualities of this age as described by Sri Yukteswar. So it's 2,400 years long. We're only 300 years and change into it. So you can expect a lot more development in the direction of Dwapara Yuga for another 2,000 years plus. So I would say you ain't seen nothing yet. It's a time when Sri Yukteswar said the human intellect can understand or comprehend the fine matters and electricities. So he was writing about the Yugas in 1894, before the turn of the 20th century. And at that time, fine matters were the way they referred to what was the emerging study of atomic structure. And they hadn't really identified the kind of structure that we have today as we understand it, with atoms, electrons, nuclei, with subatomic particles, and on and on. So he just referred to them as the fine matters, as it was referred to in his day, and the electricities. So the electricities was really the generic term that we now use, which is just energy. And because of that, we refer to this time as the energy age. So rather than today talking about the past, how ancient knowledge sort of explains the anomalies of the past, I'm going to look forward. I'm going to show how the ancient knowledge that is basically embedded in the chakras, or embedded in the yugas and in the chakras, gives us the ability to look forward to what might happen in the next few hundred or few thousand years. So Sri Yukteswar made 3 predictions. Oh, I already mentioned that he had written this in 1894. It was put in book form in 1920, but he actually wrote it before the turn of the century. So he made a number of predictions about what our ascending Dwapara Yuga would bring. One of them was that mankind would understand that matter is energy. So at the time of writing, what we think of, or what was called classical physics, ruled the day. Classic physics said that you have matter, you have energy. They're discrete things. They interact. Energy makes matter behave in certain ways, but they're different from each other fundamentally. In 1905, Einstein published his special theory of relativity, from which we get this famous equation E equals mc squared. But E equals mc squared basically means that energy equals matter in this equation. M stands for matter. And this became known as the matter-energy equivalence. So not only did we go from an appreciation in that sort of beginning of ascending Dwapara Yuga from 1700 to 19, go from that appreciation of the fact that there are energies that can be harnessed that are not something you can sense, there's not something you can see, they're more subtle, the energies that were discovered, like electricity principally, but electromagnetism in general, were sort of puzzled out over that 200-year span. But again, they were considered to be separate principles from matter. So suddenly when the Dwapara Yuga begins properly in 1900, almost immediately, we see this declaration that essentially there is no matter. That matter is just energy sort of condensed or congealed or held in patterns, moving patterns of energy that are the basis of the atoms, the molecules, the structure of all matter. So this was a mind-blowing discovery. It took maybe half a century for the general, even scientific community to kind of catch up with it and embrace it. And it's still, even today, a bit of a head-scratcher for people, because it's so easy to keep in mind or have in mind this image that there are indivisible, tiny balls of solidity somewhere down, slice the atom as far down as you want, but eventually you're going to find these. But in fact, they don't exist. It's all energy. Sri Yukteswar also predicted that in this ascending Dwapara Yuga, that there would be a rapid expansion of knowledge in all departments. Don't really need to explain this very much, because we are in a sea of information these days. We have so much information available and being exchanged that it heats up gigantic buildings to the extent of being able to serve that through the internet, that they now want to put them in the Arctic so that they have built-in air conditioning. There's just this massive amount of information available, in fact, in all departments. Sri Yukteswar also predicted that mankind will overcome the limitations of space. And this is really what I want to talk about today. So we've already overcome many of the limitations of space, the primary one of which is distance. So when you have space, you've got objects that are apart, some of them very far apart, and so we live with distance. It's just a normal part of our reality, living in these physical bodies. But we're always trying to overcome it. We get in cars to go somewhere. We talk on the phone to talk to somebody who's far away. So this Dwapara age, in some ways, the hallmark of our initial expansion into this understanding has been this overcoming of distance. So when there's a famous story about Darwin actually submitting his paper on the origin of species after Wallace had already discovered it. And there are purists who call it the Darwin-Wallace theory or the Wallace-Darwin theory. But the reason why Darwin got the credit is that Wallace was on the other side of the Earth. And when he published his paper and sent it, it took 6 months to get to the Royal Academy in London. And this is the late 1800s. So from that to today, 150 years, we now can communicate instantaneously around the world for all intents and purposes. We have, video can go around the world. We have high-speed transportation. So you can see that it's kind of this natural desire to overcome that limit. But there are hints in the writings of Yogananda that we're going to go much further with that overcoming of the limitations of space, such as space travel. And I want to give you a very different picture of how the universe is constructed to then be able to give you some hints about how might we achieve space travel. One of the limitations of space travel, we know we can put somebody in a spacecraft and we can send them in the direction of a nearby star, but they'll all be dead by the time they get there, right? So we don't really have practical space travel at this point. So keep that prediction in mind and then go on a journey with me. That was a fascinating journey for myself. That is a major piece of my book, The Physics of God. And it starts with this notion that energy is everywhere. So not only is matter itself energy, there is energy all around us that is not formed as matter. And you could say that there is energy in space. And in fact, there is lots of energy in space. Both relativity theory, which is the theory of gravity for the most part, the special theory of relativity focused on electromagnetism, the general theory of relativity focused on gravity, and quantum physics is almost purely about energy. And I'll get into this deeper and deeper. But both of them require that there be, you could think of it as free energy, vacuum energy, energy in space. But for their equations to work, they both need this energy. Now, they really disagree on how much energy. And this is one of the reasons why you've probably heard this before, that the equations of relativity and the equations of quantum physics just don't match up. If you try to use relativity's equations to describe the behavior inside an atom, it just breaks down. If you try to use quantum physics equations to determine what would happen in a black hole, it breaks down. So you've got the really large and the really small, and they don't seem to be able to meet. And one of the big differences is this assumption of how much energy there is floating around available. So with relativity, it needs what's called the constant, the cosmological constant, and more modernly, dark energy. So back when Einstein was first presenting the general theory of relativity, he had to come up with an arbitrary number or an arbitrary quantity of energy that existed in space. Because otherwise, even though his equations were elegant and self-integrated, they didn't match the reality of the behavior in astrophysics. So he was forced, in a way, to say, well, there must be X amount of background energy always present. When he put that in, his equations matched up perfectly with observed behavior. So they could predict the motion of the stars and the planets and the other galaxies, and it all just worked really neatly. But one of the things that he had to do in order to come up with his number that he just kind of pulled out of the ether was that he had to decide that the universe is static, that it's neither expanding nor contracting. And it was not long after he published the general theory of relativity that Hubble discovered that, in fact, the universe is expanding. And this was why, for those of you who know some of this lore, Einstein said that the cosmological constant was his greatest blunder. Because it wasn't tied to anything. It wasn't based on anything except this assumption, which turned out to be completely wrong, that the universe is static. So now we know the universe is expanding, and they factored in this knowledge, and they increased the amount of energy that they put into the cosmological constant. Well, then, in the latter part of the 20th century, they discovered that not only is the universe expanding, it's expanding in an accelerating rate. So the rate at which the universe is expanding today is slightly less than what it's going to be tomorrow. So things are not only expanding away from us, they're expanding away from us faster and faster and faster. This really blew everybody's mind, and this is why we have conceptions like dark energy. So back in the day, to steal Oldsmobile's slogan, back in your father's day, the universe was not only static or expanding at a very modest rate. The majority of what they were measuring to understand how the universe worked was visible matter. It was the stars and the gases and the nebulae and the planets. And they would calculate just how much matter there was in the universe, and they would refine those calculations over and over and over again. But essentially, matter was the key determinant of the gravitational impact on the universe. That by measuring matter, you could understand the distant effect one galaxy has on another. Now, that is completely reversed. The biggest impact on gravitational motion, gravitational effects in the universe, is energy. And dark energy is dark because it's undetectable so far and is really very much a theory. But they need for approximately 75% of all the gravitational effects in the universe to be the result of dark energy. And then 22% roughly is the result of dark matter, which they still don't really know what that is either. And it leaves less than 5% of the overall gravitational effect is caused by matter. So there's one big change from your father's universe, is that it is an energy machine. It's not really empty space full of matter floating around in majestic cycles. It is an energy machine that they're only beginning now to grapple with because dark energy is relatively new. So then quantum physics needs energy to be freely available in the fabric of reality because according to their equations, there is a constant creation of virtual particles taking place everywhere and even in the middle of space, and that pairs of oppositely charged virtual particles come into being and annihilate each other more or less continuously and constantly, and that this has given rise to this notion of quantum foam, that the quantum background to reality is this seething cauldron of energy coming into being, annihilating itself, coming into being. And here's the mind blower, is that according to quantum physics equations, they need up to 122 times more energy to be present in the fabric of reality than relativity does. And this is one of these fundamental disconnects in a very more specific way between relativity and quantum physics. One needs 122, I can't say it. Forget it. One needs 122 times more energy than the other. And this has yet to be reconciled. There is no solution to this yet. Yeah, well, there are things saying, but those two basic theories haven't reconciled. And this is really why string theory was born. Everyone has probably heard of string theory by now. And it may in time be able to reconcile these two. But it's a little bit like an approach of creating a third language that can be translated into the first language and can be translated into the second language, so that in a roundabout way you can translate language 1 to language 2. And what it does is it posits that there is this huge reservoir, this huge underlying ocean of energy that exists, that is made up of these tiny rings and strings of vibrating energy. And they're as much smaller than the atom is smaller than the human body. So the atom is generally on like the billionth scale. So the atom is a billionth the size of the human body. And the rings and strings that they're positing are a billionth the size of the atom. So we're talking undetectably small rings and strings. Now, what they are positing is that some of this energy exists in the 3 dimensions, which satisfies relativity's need for its amount of energy. But the vast bulk of that energy exists beyond the 3-dimensional universe. It exists in other dimensions. So enter M theory. M theory is a string theory. It's the perhaps most well-known, certainly the one that's the most highly regarded. And M theory suggests that they exist in a region, a realm, outside of the physical universe altogether. There are some theories that say all that energy is kind of wrapped up in our physical universe. And they talk about these tiny little dimensions that are packed with energy. M theory goes the other way and just says there are these enormous dimensions beyond the 3 dimensions of the physical universe that are just packed with energy. And each of these regions within that are called branes. And they call it the bulk, as in the bulk of reality. I think this is maybe the worst term that has ever been come up with by scientists to describe something so cool. So I have just arbitrarily decided to call it the energy verse. So the energy verse is so vast that it basically could give rise to unlimited numbers of other universes. So this is really why it's not your father's universe. We think of our physical universe as mind-manglingly large, and I pretty much agree with you. We can't visualize 13.5 billion light years of distance to the far edge of the universe. And it's very hard to visualize the fact that if you traveled in a straight line towards the end of the universe, you'd never reach it, even if you could take 13.5 years of travel to get there, because light bends, the universe curves its experience. So imagine an unlimited number of universes popping up, universe bubbles, in this vast ocean of energy And you have a very different conception than just what talking about our single universe gives us. So the other thing that M-theory does is hard for us to visualize, is that the structure of this brain world, these zones of energy, is two-dimensional. So one way to think about that is that energy, which vibrates in opposites to itself, only needs to have two dimensions in which to exist. Matter requires that third dimension, but energy itself can exist happily in only two dimensions. It is spaceless, or in the terms of quantum physics, it's non-local. So non-local is another relatively confusing term used by physicists to talk about other realities that are non-local. And what they're saying is they don't behave like our local reality. That there are other rules that pertain in this non-local reality. And one of the rules that pertains in our familiar three-dimensional reality is distance. Things, not only are they far apart, but it affects things like the propagation of energy. We probably all know that a magnetic field gets weaker and weaker and weaker the farther it gets from the source of that magnetism. So that's just one example of local behavior. But try to imagine, and it's hard, I wrestle with this all the time. I kept wanting to come up with a vocabulary to describe a two-dimensional spaceless realm, and I fail every time. I mean, even just the word realm, suggests space. It suggests size in the way we think of space. So you just have to do the best you can to imagine this, and it will bend your mind a little bit more as I go along. It also interpenetrates the three-dimensional universe. So you can think of the universe as being like a bubble, or, which is a valid sort of picture of it, but you can also think of it as being like a sponge. And so it's a sponge in an ocean of energy, and it soaks up and is completely permeated with that energy. But because the wavelength of that energy is so high, it's undetectable to us. But it is intersecting physical reality at every point. And in fact, and I don't have time to go into this a great deal, the physical universe would not exist if it couldn't draw on the energies that interpenetrate it. It doesn't draw on all the energies, as I've said. There are some that kind of are pulled into a detectable form that allow us to satisfy the equations of relativity, but most of it remains in this quantum realm, below detectability. But it's everywhere. It's also multi-layered. So I mentioned the brains. Brains is another confusing word. It's a contraction of the word membrane. So a brain is something that separates. So even though you have this vast ocean of energy existing, again, vast ocean, both require space. Just do the best you can to think of it in two dimensions. But even in that, it exists in areas of higher and lower energy density. So you've got really high density brains that are really kind of the top level, and then you get less and less energy as the wavelength gets larger and larger towards the lower brains. And M-theorists play around with what are called brain world scenarios. How many levels are there? How many brains are there? How do they interact? All with the goal of eventually explaining how that supports the creation of the physical universe. So however much fun they might have speculating on the structure of the brain worlds, it has to eventually add up mathematically to model the behavior in the world that we can measure. But there's a lot of different ways they do that. I don't have time to go into this, but it was one of the most inspirational, fun, satisfying connections that I made in the physics of God, and I go into it at some length in the book. Every religion in the world, every major religion in the world, has the concept of multi-layered heavens. There's the seventh heaven. There's the sense of higher and lower heavens. Muhammad was taken up in a dream by an angel, and he was given a tour of all 7 heavens, and he arose at the highest, which was the 7th level. Many brain world scenarios have 7 layers. And I think, obviously with nothing but my own enthusiasm to back it up, that M theory is deducing the astral worlds for completely different reasons. They're trying to explain how the physical universe manifests and operates. But in order to do that, they had to posit this other vast reality to support it. And the structure and the fact that it's spaceless and two-dimensional, if you read the testimony of saints and sages, and especially if you read stories from near-death experiencers, they very much talk about their experiences in the heavens with this two-dimensional aspect. For example, they're often given tours of heaven, and they're shown around. And if they get interested in something that is far away, they begin walking towards it, but then suddenly they're there. There's no distance between, other than just the thought, and I want to be there, and suddenly they're there. That it behaves more like you would in a movie, where you can have any kind of special effect you want, than to any rules that are like space and distance. And many of the near-death experiencers often refer to it as just a pure energy world. So I hope someday this can be, in fact, proven out. But I'm very strongly of the opinion that essentially science is having to deduce the presence of, where we go when we die, where we go before we reincarnate again in three-dimensional reality. So the other thing that M theory does, which is fascinating, I'm sure all of you have heard this. It's been popularized. It's been made fun of. It's been spun out into a million different theories. But few people know that the holographic principle is a must-have in M theory. In other words, M theory depends on this notion that the physical universe is a three-dimensional holographic projection of the two-dimensional energyverse. Otherwise, they can't explain how the three-dimensional world is created. So here we are in the original land of Disneyland, and probably everyone here has been to see the haunted house and seen the ghosts come out of the walls and stuff they're three-dimensional. They're kind of, spectral and vague, but that's really only because they don't have super high resolution. But the key, though, is to realize that they're not pictures like you see on a movie screen, because you can move around them and you can see things on the other side of them that you can't see from the front. They really are three-dimensional images rather than two-dimensional. And it's this law of going from 2 dimensions to 3 dimensions that was what it satisfied one of the major puzzles of M theory, which is to go from this 2-dimensional brain structure suddenly into 3 dimensions. Fortunately, there was a a good body of mathematics already developed for holography, which allowed people to, create the ghosts at Disneyland, etc. So this often blows people's minds, and they say, well, gosh, does that mean it's not real? Does that mean that there is are we a computer game? That's one of the favorites. Are we all just in a computer game and there's some being elsewhere who's playing us? I suppose in some dystopian vision that could be true, but it's not really what's intended. What they're saying, though, and this is crucial to understanding it, they're saying that the information that creates the three-dimensional universe, the laws, the forms, the templates, even the plot, even the timeline, exists in the two-dimensional energyverse. And it doesn't exist in the three-dimensional world. And this was discovered, you've probably heard about the Heisenberg uncertainty principle, where you can only know one piece of the puzzle. You can know how fast a particle is going, but you can't know where it is, etc. What they found from all this sort of quantum weirdness, is that matter, when it forms, had no predetermined properties. It just forms as it forms. And you can't find those predetermined properties in the matter itself. And this was answered in the notion of the holographic principle, saying, well, the information lies beyond this world. So I could keep going on this, but I want to get to how all this has anything to do with overcoming the limitations of space. So you've probably all heard of entanglement. Entanglement, as simply as I can put it, says that if you can twin photons, or you can twin atoms, generally by essentially splitting them, so they start from one entity and they become two, and then you send them in opposite directions, invariably, if you measure the one that went that way, and then you measure that one afterwards, they will always have opposite properties, of opposite spin, they'll have opposite charge, etc. And theoretically, they could be across the universe from each other when they're measured, and they would still always have opposite properties. This drove Einstein crazy because he thought that violated the speed of light, which is fundamental to relativity, fundamental to the way in which our three-dimensional universe behaves. And so he said there's no way that information can travel faster than the speed of light, and therefore entanglement must be wrong. Unfortunately, entanglement has been shown to work over and over and over again. So what is happening? Why is it that this information can be communicated from one twin to the other faster than light? And the answer is that they are in the two-dimensional universe until they're observed. So the moment they're observed, they come into the three-dimensional reality, and then there is distance. But the instant before they were observed, they were inseparable. They were one. There was no distance between them. So the information did not have to travel at all, let alone faster than the speed of light within this universe. So this opens up the possibility that we could communicate not only super fast on our Earth, which we're already doing effectively, instantaneously, but we might be able to communicate with other beings in other parts of the universe. Now, we're a long way from exploiting that possibility, but it may be exploitable because then we eliminate that part of distance for communication. Now, there's another theory in quantum physics that you hear a lot about, which is superposition. And superposition also has to do with this, when you observe things, they kind of pop into being, pop into three-dimensional reality. Superposition posits that because it's just an energy waveform, it could be anywhere and literally could manifest, an atom could manifest anywhere in the entire universe, but it manifests right there when all the probabilities kind of come down to the one final choice. But that it potentially could be anywhere. So again, understand this, you have to realize it's this two-dimensionality. Two-dimensionality in this energy verse can be, it can come out anywhere in the physical universe because there's no distance between it in the two-dimensional. Bends the mind, right? So again, there's the possibility that this could be exploited. That's in some way, and I'm talking, as I say, we haven't seen nothing yet. We've got 2,000 more years to go in Dwapara Yuga. I'm not expecting any of us to be, mailed to Arcturus anytime soon, but maybe in the hundreds of years kind of time frame, they'll figure out how to exploit these things. And they had no idea what to do with what they learned when they did the initial cyclotron experiments where they split the atom, but now they use that knowledge to run computers and to do many of the things that underpin our society. So they just need to figure out, how do I put that to actual use? So this notion of superposition could mean that we could instantaneously create matter anywhere in the universe. And there are some hints of this in what are called quantum teleportation. And quantum teleportation sounds like we're already there, right? That we are on the pad in the Enterprise and we could send something to the nearby planet. But quantum teleportation is really quantum duplication. It's more like a copy machine process than in actually moving matter from one place to another. So what they've been able to figure out is that they can measure the quantum state of an atom or a bunch of atoms, and then they can reproduce that exact quantum state some distance away. So you get two atoms, if you will, if they're just doing it with one atom, with exactly the same properties than the one you went with. So, we could use templates. We could send stuff to Arcturus. I don't know what the Arcturians would think of whatever we sent them, but in theory, we could exploit that principle. Then there is another concept that I'm sure all of you have heard of, wormholes. This is a favorite of many, many science fiction programs, novels, memes, is this notion, and this was also suggested as a reality by Einstein, ironically. The irony with Einstein suggesting entanglement was that really what he was trying to do was say, look, this is impossible. Nothing can be entangled. So your equations must be wrong. But that completely backfired on him, because then they proved that it could be entangled, and his whole argument went out the door. So he also predicted wormholes, interestingly enough. And the notion of a wormhole is that you can go from one part of the universe to another part of the universe through this shortcut. And I'm less sure, or it seems even more speculative to me that you could actually move matter as we know it through the two-dimensional energy verse and come out somewhere else, but who knows? But the notion that you could have a channel, you could have some kind of fixed pathway between one part of our universe and another that goes through this two-dimensional world may not be so far-fetched. So these are just fun ways to think about what Sri Yukteswar might have been implying with overcoming the limitations of space. I think the potential is enormous, and there was more than a hint in Yogananda's and Sri Yukteswar's teachings that there would be space travel in our future. One intriguing thing that Yogananda said is that we'll be able to travel through space when we learn how to cooperate with the forces of reality rather than working against them. So when we're shooting these rocket ships up into the air and getting them into orbit, we're just really pressing hard against the other reality, right? The payload of a rocket ship that puts a satellite in orbit is like 1/1000th of the weight of the rocket. The rocket itself and the fuel is most of it. So we're just forcing it. But someday we may figure out, how do we cooperate? How do we just kind of quietly slip through the shortcut of the energy verse? So thank you very much.